Welcome back everyone, and welcome back to episode 6. We're moving into part 5, which is all about indexes. So I'm going to explain to you what those are all about, how they're used, and how to create those objects. So let's move on in to SQL Server Management Studio. Okay then, let's head on in to Wide World Importers. And we're ready to go. So, indexes then, what are they all about? Well, indexes are normally put on tables within a database in order to speed up the way that SQL Server searches for and retrieves data when you run off queries, etc. It's a very simple methodology behind it, and it can be very, very efficient. So normally, if you do not have indexes and all your data is not sorted out, then SQL Server has to go row by row down from the top of a table, searching for the data you're after until it finds it. With indexes, they tell SQL Server exactly where to find the data, so it can go straight there and retrieve the data you want within all your select statements. Now, indexes are normally set up by database administrators. They will do their diagnostics every so often and put in indexes to speed things up. If they find that people are running some very laborious and long-running queries against the database, they might then implement some indexes where they can to sort those out. So normally you as a developer won't get involved in creating indexes, but it's good to know all about them, what they do, and how they can help you out in certain situations. The first one we're going to look at is the clustered index, and we've already created some of those when we built our primary keys in the previous video. So primary key by default is a clustered index, and all it means when you have a clustered index is that it will sort the table, in this case when we create the table here, and we have the primary key on the customer ID, it'll actually sort the data physically on that table when it gets stored on the disks. So that way SQL Server knows exactly where to go to because all the data is sorted. So if you imagine you have a book where you have an index at the front and it has a list of contents with the page numbers against them. So you know that if you need a specific bit of information and you look in the index, you see that it's on page 20, you can go straight to page 20. Well, the concept is very similar in so much that SQL Server will know exactly where to go to retrieve the data that is being queried. So let's see this in action then. We're going to create this table, customer name 2, and we're going to just put in the customer ID and customer name. There we go. And to create our primary key index here, which is a clustered index, it defaults to clustered. We could write clustered there and it'll be fine, but we don't need that because it defaults to clustered there. And when we place the constraint on the customer ID, by default it will sort it in ascending direction if you leave that blank. So let's see what that looks like then. Let's execute that, and we've now got our primary key. If we have a look in the Object Explorer quickly, customer name, let's refresh that. Here's customer name 2. So if we go down, look at our keys, we've got our primary key. If we then double click on that, you'll see a bit of information there. close that down, right click, and if we script key as create to new query window, you'll see a bit more information here. It specifies its primary key clustered, so it automatically defaults to that type of index. So let's put in some data quickly and see what we get. Just the 10 rows, as you've seen. Let's select from the table, and as you can see, it's sorted by lowest to highest, so ascending on the customer ID. So SQL Server knows that this table has this index, so when it wants to find the Tailspin Joy's Jesse department there in that city, it knows it straight away. It goes to customer ID 6 and it can pull that information in the queries really quickly. So what if we wanted to put descending instead on the primary key? Let's drop that table quickly, and that'll drop any keys associated with it or any indexing. We'll create that table and the index again, putting descending there. We'll put in those top 10 again, and we'll have a look and see what the results look like. As you can see, it's sorted it the other way around. Now it doesn't matter which way you sort it, ascending or descending. Why you'd want to sort it descending is beyond me, but you might just want to do that. SQL Server knows that it's descending, so it will still be able to find the data you're after just as quickly by looking at the primary key, the clustered index on that column. Now, if we add more rows into there, so all we're saying is to select these where the customer ID is between 11 and 20. Let's put those in, and more on this coding here in a later episode. Don't worry too much about that for now. Let's insert those rows. 10 rows went in, and if we then check the data, you can see it's still sorted. The whole lot is sorted in reverse order there, so it knows to put them in the right direction because it's still on descending. And that's pretty much it for the clustered index. Key thing to remember, the clustered index, is that it sorts the data physically when it stores it. So if you were to select off the table, it would automatically come in this order that you specify without you having to order the data by. Another key thing to note with the clustered index is that you can only have one clustered index on the table itself, normally the primary key. And again, you can only have one primary key on the table as well, mainly because the data is physically sorted on the table, so you can only have it sorted in one direction. That's a clustered index for you. Now there are other indexes that we can apply in mainly the non-clustered index. And the way that the non-clustered index differs from the clustered index is that the non-clustered index is actually stored as a separate table of values outside of the actual table itself. So while the index is stored within the table itself because it's sorted in that direction, here the non-clustered index is sorted elsewhere, it's stored elsewhere. So if you have hundreds of thousands of non-clustered indexes, you might find your disk space filling up rather quickly. But non-clustered index definitely have their place when you find that you're hitting a specific table quite hard in your queries and they're very slow. Sometimes a non-clustered index will really speed things up. So how do we write one then? We can simply create index. Here we haven't specified anything, not primary key or anything like that. We simply put create index. Then we give it a name, and you can either put IDX or once again just use your company's standard coding standards. So we're going to call it this name here, and we're going to create it on this table, which is customer name 2, and we're going to create the non-clustered index on customer name. Now again, you can type ascending or descending, or just leave it at the default of ascending. So what this is going to do is build an actual index on the customer name itself. Let's have a go, see if that works, and it's good to go there. Now let's have a look. If we refresh this table here and we look at indexes, you'll see here we've got IDX, so we've got our primary key indexes there along with our primary key up there. As you can see, it says clustered index there. And then we've got our customer name 2, the one we've just set up, non-unique, non-clustered. So we've created our index. Now, for example, if we're pulling that data or we're joining to pull that data, we should get a much quicker result when we query that table. Now you can also create indexes using multiple columns. So if we look at our invoice lines table quickly, you've got an invoice ID here, but unfortunately our invoice ID is not unique. So we can also include the invoice line ID as an index on there. And that's the difference between the normal create index, which is the non-unique, and the unique index itself. So what we'll do is we'll create the index, see if it works. So we're creating on an index on multiple columns here. There we go. So we've got that one there. Now a unique index, the difference between the unique index and the non-unique index is that this index will still work even when you've got duplicate values from the invoice ID and the line ID combination here. So let's have a look at invoice lines again. As you can see, we've got 2 invoice IDs there. So we cannot create a unique index on there because we've got duplicate invoice IDs. Let's give that a try. As you can see, it cannot create it because duplicate keys were found. And that, as you can see on the invoice ID, there's duplicate keys coming in there. There's 3 4s, there's multiple 5s, and so on. So it can't create a unique index. However, if we bring in the invoice line ID and we do that, that's fine, it works, because if we do a combination of invoice ID along with line item ID, as you can see, 2 and 2, 2 and 3, that's a unique combination that's not repeated anywhere else in the table. So we have our unique index. Normal non-unique, you can create it on rows that are duplicates. So for example, we knew that the invoice ID was duplicated. We're going to put that as 1. And this failed on the unique index, if you remember. If we execute it there, it's fine, works just fine, because we haven't specified unique. So that, everyone, is a quick run through of indexes. Again, it's more a case of giving you a heads up on what they're all about, but you probably won't be getting involved too much in building loads of indexes, especially when you begin your SQL career. So the key thing to note with the clustered index is that you can only have one on the table, and the primary key normally defaults to a clustered index. This is because the data is physically sorted by the clustered index itself when it stores the data on the hard drive. Whereas your non-clustered indexes, they are stored on a separate table that the SQL Server manages, and that takes up additional hard drive space. And of course the difference between your non-unique and your unique indexes is you cannot create a unique index on a column that has got duplicate values in it. They need to be unique. And also you can create indexes on multiple columns at once. That's it, everyone. Thank you for joining me for part 5. Hopefully we'll see you soon in part 6. Until then, I wish you all a fantastic day.